All right, so let's continue with CS50's Introduction to Programming with Python, Lecture 5. Lecture 5, we cover testing or tests, unit tests using assert, pytest, testing strings, organizing tests into folders, and summing up. So what are unit tests? Up until now, you have been likely testing your own code using the print statements, which is a good place to start. Alternatively, you may have been relying on applying CS50 to test your code for you. It's most common in industry to write code to test your own programs. In your console, type code calculated with Py. Note that you may have previously coded this file in the previous lecture. In text editor, make sure that your code appears as follows. Let's create a file, Python file called calculator, Py. This code should be quite familiar. This code. Notice that you could plausibly test above code on your own using some above numbers, such as 2. However, consider why you might want to create a test that ensures that above code functions properly. So let's just try this out. So percent run calq later 2. There we go. It works. So we've tested it to make sure it works. Okay. Which is useful and important to do. So again, you might create a test that ensures above code functions properly. So following conventions, let's create a new test program called test calculator.py and modify code in the text editor with the following. So now we go into create a new file, test calculator. Paste this code. What does it do? Well, this imports our file we just created as a module. So imports calculator.py and finds the function square and imports it. Then we have our typical main function that runs test square. What does test square do? Well, it calls square the function square2 and puts the input value 2 and checks if it's not equal to 4. Print 2 squared was not 4 and 3 not equal to 9. 3 squared was not 9. And then this is obviously the entry point to the code. So in the console window, type pytest calculator. So let's first see what happens when you run the code. So we have certain test conditions that we are running. Oops, nothing happens, which is actually correct. The console window, notice nothing is being outputted. It could be that everything is running fine, which is what you expect. Alternatively, it could be that our test function did not discover one of the corner cases that could produce an error. Right now, our code tests 2 conditions. If we wanted to test many more conditions, our test code could easily become bloated. How could we expand our test capabilities without expanding our test code? Let's go back here. So again, we're just checking 2 cases. 2 squared should be 4, 3 squared should be 9, right? If not, it'll give an error. So let's maybe break the code. As it says, let's add a +1. This will break it. Settle. This one. Let's try it again. I think I probably have to save this again, maybe. It's definitely not giving the correct output, probably. Have to rerun the terminal again, restart the terminal. Restart the terminal. Because I changed the file, so just to recognize that it has changed. Once again. Yeah, there we go. So 2 squared is not 4, 3 squared is not 9. That is run, so let's restart the terminal. let's go back and save it again. And then we're just testing, making sure it does work. Kernel, is that kernel? Start. Okay, so this is just testing how it works. Now, assert. Python's assert command allows us to tell the interpreter that some assertion is true. We can apply this to our code as follows. So let's just make sure this runs again correctly. Yeah, it doesn't give us anything. Now we can change our code. Says the same, says the same. Now, instead of these if statements, we can use assert, which pretty much is the same thing. Notice that we are definitely asserting what square 2 is and square 3 should equal. Code is reduced from our 4 test lines to 2. And we can purposely break our calculator by modifying it as follows. We can say it's in. It's in. Save this again. Reset the kernel. Then gives an assertion error because that test failed. Notice that we have changed the times operator to plus in the square function. Now running the code in the console, you'll notice that an assertion error is raised by the interpreter. Essentially, this is the interpreter telling us that one of the conditions was not met. One of the challenges that we are now facing is that our code could even become more burdensome if we wanted to provide more descriptive error up to the users. Plausibly, we could code it as follows. We use try and accept for various test cases instead. Make this. So instead of breaking the program, it would just give a printed error. So 3, 9, minus 2 is 4, minus 2 is 9, 0, 0. Let's run it and restart the terminal. Notice that this code will produce multiple errors. However, it's not producing all the errors above. This is good. Illustration that's worth testing multiple cases, such as it might want to catch situations where there are code mistakes. Love code illustrates a major challenge. How could we make it easier to test your code without dozens of lines of code like above? Because then more what's certain in this case. So in many cases, you don't want to have, you might have code that you don't need to test like all situations, only 1 or 2. But there are codes, like in this example, we want to test all cases. So what is that? So pytest is a third-party library that allows you to do unit tests to unit test your program. That is, you can test the functions within your program. To utilize pytest, please type up install your console window. Let's see if I can actually get that to work. I'm not sure. For applying pytest in program, modify test square as function as this one. Okay, so this is what they want us to do. Let's change this before we try pytest. Otherwise, you have to go to Visual Studio Code. Okay. So pytest allows us to run our program directly through it, such as we can more easily view the results of our test conditions. Terminal type pytest calculator. You'll immediately notice that the output will be provided. Okay, now we use it, pytest calculator. You'll immediately notice that the output will be provided. Notice that red F near the top of the output would show something that you can use. All right, so pytest does not work in Jupyter Lab, unfortunately, or not very easily. So I just went to VS Code to do the same thing. So yeah, so let's go back to our code. So we're gonna run this. Well, install a pytest is usually actually pre-installed already. If you send Python like on your machine, otherwise you put install. So I'll copy this code. Here it is. I have my calculator code there as well. So fine. Notice how the above code asserts all the conditions that we want to test. PyTest allows us to run a program directly through it, such as we can more easily view the results of test conditions. In the terminal window, type PyTest calculator. You'll immediately notice that the output will be provided. Notice the red F near the top, indicating something in your code failed. Further, notice that the E provides, what is the E? Oh, here's the E. That the E provides some hints about the errors in the calculated program. Based upon the output, you can imagine a scenario where 3 times 3 has outputted 6 instead of 9. Because the results of the test, we can go correct calculated pi as follows. So, correct it. They run it again. And great, it gave no error. Notice that we have changed the plus to star, the square function, returning it to working state. Running pytest calculator, notice how no errors were produced. Great. At the moment, it is not ideal that pytest will stop running after the first test failed. Let's return our calculator code back to its broken state. Okay, yeah, we will just, so we don't want the program to break. That's what they're pretty much saying. So let's break it. Well, let's break the code again. Let's find a better way to handle the error. To improve our test code, let's modify test calculator to divide the code into different groups of tests. So we have test 0, test positive, and test negative. They're just different functions that do the same thing. Okay, copy it here, go to here. It's there. Notice that we have divided the 5 tests into 3 different functions. Testing frameworks like PyTest will run each function, even if there was a failure, one of them. If you're running PyTest calculator, you'll notice that more errors are displayed. More error output allows you to further explore what might be producing the problems within your code. Okay, let's try it again. And this is actually quite nice. It shows it's a problem with test positive. There's a failure. There's a problem with test negative. There's a failure. Test 0 was fine. So it's nicer to, or better, when doing this, to separate your tests into functions. Quite useful. Having improved our test code, return our calculator to the fully working order. So this changes from plus to multiply. Once again, it should work properly. Notice that we have changed plus to star and it's working again. Running test by calculator, you'll notice no errors. Great. Finally, we can test a program handles exceptions. Let's modify test calculator to do just that. So yeah. So let's try this now. So we haven't even imported pytest, but that should be okay because it's built into Python, so don't have to worry about it. So I'm testing a situation where there is a string. So let's move this back. Like that. Test string. So is the error if you get a string like that. Notice that instead of using assert, we are taking advantage of a function within pytest called raises over here, which allows you to express that you expect an error to be raised. We need to go to the top of the program and add import pytest. Okay, all right. That's why I should for this one. So let's add it. And call pytest raises what the type of error we're expecting. Then you run it and notice the errors are found. In summary, it's up to use a coder on as many test conditions as you see fit. You can check out pytest as a Py documentation. That's all just fine. Going back in time, consider the following code hello. Okay, let's go back to hello code. Do we need pytest here? Yeah, we need pytest. Okay. Let's go to hello code. Create another file called hello. Py. Going back in time, consider hello code. Let's copy and paste this. Pretty straightforward. We have a modular program, a function, true for hello. Give a person's name and you say hello to the person. This we may wish to test the result of a low function. Instead of this example, we have another one called test hello. Test hello. Okay, and this is how we test it. And looking at this code, do you think there's approaches to testing work will work well? Why not test why might this test not work well? Notice that hello function and hello pi print something. That is, it doesn't return a value. We change a hello function within hello as follows. So we need to return the value somewhere, somehow. So let's just change this over here to this. We're changing this as well because we're getting a result now, and then we are returning this. So this is what we need to do. Notice that we change our hello function to return a string. This effectively means that we can now use a pytest to test the hello function. Running pytest hello. Let's see what we get. We get pytest hello. Not that one. Pytest hello. And all worked fine. As with our previous test in this lesson, we can break it into a separate test. For example, test hello, we can break it up. Again, if there are errors, it would help to test in different default and an argument, for example. Right now, it should work fine. Organizing tests into folders. Unit testing using multiple tests is so common that you have the ability to run a whole folder test with a single command. First, in terminal, execute make dir test. Okay, make dir test. Then to create a test within the folder, type in the terminal. This should work as is. Yeah. Notice that test instructs the terminal to create a test hello in the folder called test. The text editor window, modify the file to do the following. Okay. Notice that we are creating a test just as we did before. PyTest will not allow us to run tests as a folder simply with this file or a whole set of files alone without a special underscore in it in a score file. The terminal window create this file by saying code need this file to run the test. Notice that test folder as before, as well as a double underscore on either side of init. Even leaving this init file empty, even pytest is informed that the whole folder containing init py has tests that can be run. Now type in pytest in the terminal, you can run the pytest folder. That's pretty cool. You can run a folder if you have more tests. This is error, no module find hello. This is probably because we need the file hello to be copied here as well. It should work. There we go. That's pretty cool. You can run a folder of tests if you want. Summing up, testing your code is a natural part of the programming process. Unit tests allow you to test aspects of the code. You can create your own program to test your code. Alternatively, you can use frameworks like pytest to run your own unit tests for you. It's lecture you learned about unit tests, assert, and pytests. Great. Hope you learned something. Until next time, goodbye.